Alright, welcome back to the AI Research Roundup. I'm your host, Alex. Today, we're looking at Hunyuan3D 2.0, Scaling Diffusion Models for High-Resolution Textured 3D Assets Generation, a paper published January 22nd, 2025. So, this research introduces a powerful system for creating detailed, textured 3D assets. These are essentially 3D models complete with their surface colors and intricate patterns. It's built on two main AI components. One for generating the 3D shapes using a flow-based diffusion transformer, which is an advanced AI that learns to build shapes by cleverly reversing a noise process. And another for applying high-quality textures. A really great aspect is that they're releasing this publicly to support the open-source 3D community. And speaking of supporting the community, it's great they've released the code on GitHub. The repository has inference code for running their pre-trained models to generate 3D assets, examples to get you started, and tools like a Gradio app, a simple interface to try the models, plus a Blender add-on. Okay, and this first figure really gives us a glimpse into the kinds of creative outputs possible. It's a vibrant scene, almost like a movie poster, filled with diverse characters. We've got a fox on a motorcycle, a knight, a monkey, even a dragon, all set against a fantastical backdrop with a castle and spaceships. This variety really highlights the potential of their Hunyuan3D Studio, which is their production platform designed for tasks like sketch to 3D and even 3D character animation, as hinted at by these varied figures. It's a great visual for what this system can do. So, this figure really breaks down the Hunyuan3D 2.0 system visually. On the top left, Hunyuan3D shows its shape generation prowess with intricate, untextured 3D models looking like high-resolution kit pieces. Then, top right, Hunyuan3D Paint displays its texture synthesis with a gallery of vividly colored objects. And the bottom panels illustrate Hunyuan3D Studio's capabilities like sketch to 3D and animation. A key component here is Hunyuan3D Shape VAE, which uses a variational autoencoder. Well, a variational autoencoder is an AI model that's great at compressing data, like a 3D shape, into a compact form and then accurately rebuilding it, which is crucial for efficiently creating these detailed 3D assets. Alright, this figure 2 gives us a more detailed schematic of the system. For shape generation, it shows Hunyuan3D Shape VAE using importance sampling, a method to focus on critical shape details and attention mechanisms, which help the AI weigh data relevance. The final mesh is then constructed, often using an algorithm called marching cubes, for creating a surface from data points. For texture synthesis, a key first step is image delighting to remove source lighting. Hunyuan3D Paint then uses this delighted image, with geometric inputs like normal maps for fine surface detail, before applying super resolution to enhance clarity, and then texture baking to map the texture onto the mesh. Okay, so building on that overall system view, figure 3 gives us a closer look at the Hunyuan3D Shape VAE architecture we touched on. It clearly illustrates its importance sampling strategy. See how the importance point cloud at the top visually captures much finer details, especially around edges, compared to the uniform sampling? The system then uses farthest point sampling, or FPS, which is a method to select a well-distributed set of points from the 3D shape surface. This farthest point sampling is applied to both sampling types before they go through cross-attention and self-attention layers to produce those compact latent tokens, which are then decoded into the final mesh. Okay, so after the Hunyuan3D Shape VAE efficiently encodes shapes into those latent tokens, figure 4 here shows us the architecture of Hunyuan3D, which is the part of the system that actually generates the 3D shape. It uses a transformer design with what they call double stream and single stream blocks. The input image is first processed by a dyno encoder. That's a powerful pre-trained AI model for understanding image content. Then, this image information, along with the shape tokens, goes into these double stream blocks, which allow for rich interaction between the visual cues from the image and the emerging shape, before being further refined by single-stream blocks. Alright, so after Hunyuan3D generates the shape, figure 5 here zooms in on the Hunyuan3D Paint pipeline, This is all about creating that detailed texture. We see the input image first goes through image delighting, which, as we mentioned, removes shadows and lighting for a clean base. Then it uses a reference branch to closely follow this input image, and a generation branch working with geometric inputs. A key part is the multitask attention on the right. This uses inputs like camera embeddings, which are numerical codes representing the camera's viewpoint, and combines multi-view, self, and reference attention to ensure the texture is consistent and true to the original image, leading to the dense view inference for the final texture map. Okay, so after looking at the pipeline for texture generation, Table 1 here shows us some numbers on how well the Hunyuan3D shape VAE part, which we discussed earlier, actually reconstructs 3D shapes. It uses metrics called volume intersection over union, or VIOU, which essentially measures how much the reconstructed 3D shape's volume overlaps with the original shape's volume, and surface intersection over union, or SIOU, which similarly compares the overlap of their surfaces. Hunyuan3D shape VAE scores an impressive 93.6% on volume intersection over union and 89.16% on surface intersection over union. This significantly outperforms baselines like Michelangelo, which achieved 88.43% and 81.55% respectively, really highlighting Hunyuan3D shape VAE's ability to faithfully rebuild those shapes with fine details. Those strong reconstruction numbers from Hunyuan3D shape VAE, combined with the sophisticated generation and painting pipelines we discussed, really show the power of Hunyuan3D 2.0. It's a big step forward for creating high-resolution, textured 3D assets efficiently. This kind of progress is super important for making rich 3D content more accessible for games, virtual reality, and beyond. That's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm Alex.